Imagine this: data without labels, chaos with no guide. That's the challenge of unsupervised learning. But guess what? We're turning that mess into mastery. In this project-based video, we'll take on clustering algorithms and uncover hidden structures buried deep in the data. Welcome to day 20 of the 30 Days of Machine Learning series. If you're just joining, don't worry. You can click right here to access the full playlist and catch up on every step of the journey so far. And hey, make sure to hit that subscribe button so the next video in this series drives straight into your feed. Let's import the essentials: pandas for data handling, NumPy for computations, matplotlib for plotting, and Seaborn for stylish, beautiful visualizations. Let's load the data, peek at the first few rows, check its shape for dimensions, and glance at the column names to understand its structure quickly. First, we check for missing values in each column. To handle them, we replace nulls in credit limit and minimum payments with their respective medians, ensuring balanced data. Finally, confirm no more missing values remain. Let's inspect data types and memory usage with info, then summarize statistics using describe for deeper insights. We're using standard scalar to normalize numeric columns, ensuring features are on the same scale. First, we select numeric data, then apply scaling, making our model's performance more stable and reliable for unsupervised learning. Now let's dive into data visualization by plotting histograms for the first 7 numeric columns. Each plot shows the distribution of values with a density curve overlay, helping us detect skewness, outliers, and variability. Using subplots, we organize charts efficiently, making patterns easy to observe. Tight layout keeps everything tidy, while show brings the visualizations to life. This step provides a solid grasp of feature behavior before applying unsupervised algorithms. Here, we're plotting box plots for the first 7 numeric columns to detect outliers and understand data spread. Each plot represents the distribution with quartiles and potential outliers marked, giving us a quick overview of the feature's range. We use subplots to organize the visuals, and tight layout ensures they fit well on the screen. Finally, show displays the box plots, offering key insights into the data's consistency and quality before modeling. We're visualizing the correlation matrix here to spot relationships between numeric features. The heat map reveals how variables interact with each other: positive, negative, or no correlation. By annotating with correlation values, we get precise insights. This helps us identify potential feature pairs for further exploration or modeling adjustments. We're applying PCA to reduce dimensionality, transforming the scaled data into 2 components. This simplifies the dataset, making it easier to visualize and analyze. Here we're applying k-means clustering with 4 clusters. By fitting the model to our scaled data, we predict cluster labels, helping us group similar data points for further analysis. We're using hierarchical clustering here, applying the Ward method for linkage to group similar data points. This creates a dendrogram to visually represent the clustering process. Now we're visualizing the hierarchical clustering results with a dendrogram. It shows how clusters are formed at different levels, helping us understand data relationships better. We're assigning hierarchical cluster labels, cutting the dendrogram into 4 clusters for analysis. Here, we're applying DBSCAN clustering. With a specified epsilon and minimum samples, this method groups data points based on density, identifying outliers in the process. Here, we're visualizing the results of k-means clustering on the PCA-reduced data. Using a scatter plot, each point is colored according to its assigned cluster, making it easy to see how the data is grouped. By reducing dimensions with PCA, we simplify the analysis, and the color bar provides clarity on the cluster assignments for each data point. We're visualizing hierarchical clusters on PCA-reduced data. The scatter plot shows how data points are grouped, with each cluster represented by a unique color for clear differentiation. Here, we're visualizing DBSCAN clustering results on PCA-reduced data. The scatter plot uses different colors to represent distinct clusters, highlighting how DBSCAN groups dense regions while identifying outliers effectively. We're printing the unique cluster labels for each method: k-means, hierarchical, and DBSCAN. This helps us compare how each algorithm has grouped the data, revealing different clustering behaviors. And that's a wrap on clustering. We've explored k-means, hierarchical, and DBSCAN, each revealing different ways to group data. But here's the thing: how do we tackle high-dimensional data? Stay tuned for the next video, where we dive into dimensionality reduction. You won't want to miss it. Click on the screen to continue your journey.